is not inverse, I guess. 7 might be parametric. Okay, I will check it now and confirm you. Okay.
Okay, sir.
And then Rifat, you have completed up to assignment 4th. Please complete rest of the assignments, Rifat. The questions are very important. Okay. And no one has discussed any doubt with me. That means you have not completed the questions. Because in some assignments, they are very tough questions. So you must have some doubts in that. So please complete the assignments and discuss your doubts with me. Okay. Next, I've given 2 questions from the continuity. I guess no one has done yet.
Sir, I
Okay.
have done, sir.
You have done, Abdul? Okay, great. Any doubt, Abdul, on that?
No, sir.
Okay. So one of the question is very important because the same concept we will use in different chapters. So I will discuss that question right now. Okay, this one. Abdul, you have done this question?
Yes, sir.
Okay, so Abdul, could you please tell me how we need to approach this?
So using case 1 with x equals to 1, and then by case 2 by x equals to 2.
Yeah, that's correct. But we have a modulus, so we need to define this modulus first. Okay, so I already told you that in case of modulus function, always please define the modulus. Okay, who can tell me? Abdul, can you tell me what is mod x?
So if x is less than 0, if x is greater than 0,
Greater than equal to 0, good. And minus x?
if x is less than 0.
Less than 0, very good. Okay, Fahd, you were absent yesterday. Okay, so we have done some questions. Please check the recorded lectures. Regarding the modulus function, Fahd, you might have done this in class 11. It was there in the chapter relation and functions. Okay. Yeah, this topic. Okay, please check the recorded lectures. The modulus function is what? You know that f is continuous. Okay, Rifat, very good. So Rifat, first you have defined this modulus function. You have done in the same way. Okay, great. So let me quickly complete this question. First, you already know that what is the property of modulus function. If you will put any value in the modulus function, it will convert that value into a positive value. Okay. For example, if you will put a negative number, it will become positive. If you are putting a positive, it remain positive. So what is the formula behind that? This is the formula that whenever you are putting a number which is greater than equal to 0, okay, then in that case, the mod x value will be x. So for example, if you are putting a value 3, then mod x, we have to use x only. So that means 3. If you are putting a number which is less than 0, here, less than 0 means, for example, minus 3. If you're putting minus 3, then mod x, we have to use minus x. Okay. Now, in this place, if you will put a negative minus 3, then it become a positive. So this is the formula. Okay, for this is the formula for mod x. So how can we define mod x? Mod x is equal to x when x is greater than equal to 0 and minus x when it is less than 0. Okay. Next thing, Fahad, please remember that how we get a 0 here, whatever the expression you have inside the mod, always equate that with 0. Okay. And what the number you will get, that will become your reference point. So for example, if you have modulus x minus 1, you need to define this. So in modulus, you have a value x minus 1. So put this x minus 1 is equal to 0. You will get a 1, x is equal to 1. So 1 will become the reference point. Okay. So this become what? This is equal to x is greater than equal to 1 and x is less than 1. So greater than equal to 1, it is x minus 1. And for less than 1, it is minus x minus 1. Is it clear for? I'm sorry, you are not audible. Will you please reply me on the chat box? Okay, great. Okay, Omer, we have just started this question which I have given yesterday. Okay, so I have defined mod x here, mod x minus 1. So I hope you already know about this. And one more thing, I have checked your answer sheet. So very good. Omer, you got 15 out of 15. And I guess one more student got a 15. I guess Rifat. Okay, I already share your test paper on the group. So please check your marks. Next is x minus 2. Why can't we directly substitute 1 plus h in place of x? 1 plus h. So in question 2, the answer is correct, which I wrote. Okay, okay. So for I will check. Okay, after the class, we will discuss about the test paper. Okay. Abdur, modulus. So what is 1 plus h? Why you are using 1 plus h here? 1 plus h we normally use for RHL and in some trigonometric functions where we get a 0 by 0. So why you are using 1 plus h here? Abdur, will you please unmute yourself? Yeah, okay. Abdur, first of all, let me complete this. Okay. Then I will discuss with you. So x minus 2, the reference point is greater than or equal to 2. So this is x minus 2 and less than 2, it is minus x minus 2. Okay. But now the question is modulus x minus 1 plus modulus x minus 2. So in mod question, we always need to define the modulus, then only we will solve it. Separately, we have defined here x minus 1 and x minus 2. Now, in the question, they have added these two modulus. So we will define them simultaneously. Now, what the value we will take, check here. We have four values, greater than or equal to 1, less than 1, greater than or equal to 2, less than 2. So first we will take less than 1. Okay, because there is no number which is lesser than 1. So x is less than 1. So that means, who can tell me? Firth, can you tell me if x is less than 1, this part will become positive or negative? Positive. Why positive? It is less than 1. Please check here for this one. So this is negative. Okay. Minus x minus 1. Okay, Firth, this is clear? Okay. Then please tell me the next one for less than 1, this second part, this second modulus, this will be what? Positive or negative? Fahad, this second part will be positive or negative? Negative, very good. I hope everyone understood this, that for the value x is less than 2, this is negative. Number is less than 1. So if a number is less than 1, then definitely it is less than 2. That's why we will take a negative here. So minus x minus 2. Now open this bracket, you will get a minus x plus 1 minus x plus 2. So here you will get a minus 2x plus 3. Okay, we have just opened this bracket and we get a minus 2x plus 3 here. Okay, now the next value which we will take is x less than 1 we have taken. Now we will take x is greater than or equal to 1. Okay, now who can tell me, Rifat, for x is greater than 1, this first part will be positive or negative? This one. Rifat, modulus x minus 1. This is positive or negative? Positive. Very, very good. Very good. X is greater than equal to 1. x is greater than equal to 1. Okay. Okay. So this first part is positive. I hope this is clear to everyone. You can see here, if the x is greater than 1, then it is x minus 1, positive. Now, Rifat, can you tell me about the second one, modulus of x minus 2? It will be positive or negative? The second part. Or we need to change some inequality here. We need to add some number here. Both the options you can tell me, x minus 2 is negative or positive, or you want to add some inequality here. Anyone else? Abdur, can you tell me? Positive. Okay, for Abdur, Umair,
Positive.
positive. Okay, Umair,
Positive.
positive. Okay. So here we are saying x is greater than equal to 1. Okay, for this one, for this case, for this modulus, mod of x minus 2, we are saying x is greater than equal to 1. But if we will see here, if a number is greater than equal to 1, then it is possible that it is greater than 1 but less than 2. Okay, so what we will do, we will take that condition, because greater than 1, we have two conditions. First, it is greater than 1 but less than 2, or it is even greater than 2 also. So first we will take this condition. X is greater than equal to 1 and less than 2. And third, we will take x is greater than equal to 2. Okay, this is clear to everyone why we have taken this third condition, because the second condition was incomplete. X is greater than equal to 1, it's fine. But there are chances it is less than 2, and there are chances it is even greater than 2. Okay. So I hope this is clear to you. Rifat, now can you tell me for the second one, x is greater than equal to 1, less than 2, in place of this modulus x minus 2, what we can write? Sorry, it will be positive or negative?
Positive.
If it will be positive. Who said this? Whose answer is this? Abdul.
Tell me. Umar.
Okay. Okay, Umair, positive. Let me check with others. Abdul, this will be positive or negative if the value is greater than equal to 1 and less than 2?
So for 2,
For this one, for second case. For second case, the modulus x minus 2. Okay, Rifat, I got your answer. This modulus of x minus 2, this is positive or negative, Abdul?
so it's negative.
Negative, okay. Fahad has already given the answer, Rifat. So this is negative. Okay. So this answer is correct. This should be negative. Why it is negative? This is modulus x minus 2. Your number is greater than 1, it's fine, but it is less than 2. And modulus of x minus 2 depends on 2. You can see here. If your number is less than 2, then it is negative. Okay. If anyone have a doubt, please let me know. So I hope the second is clear to everyone. Now, Fahad, tell me, okay, we will solve this. So x minus 1, we have this x minus 1 minus x plus 2. X will cancel out, we get a 1 here. Okay, so this is equal to 1. So second value, we get a 1. And who can tell me this? Fahad, Fahad, can you tell me the third one, x is greater than equal to 2? Then this modulus, we will get what? Fahad? The first one. Okay, very good. X minus 1, very good. Plus x minus 2. Both these are positive. Why both are positive? Because the value is greater than 1, greater than 2. Now we will add these two. What we will get finally? 2x minus 3. Okay, so we get here 2x minus 3. Okay, so everyone, please let me know. Is this clear? This is a very good question, and the same concept we will use in differentiability. This concept means the how we defined a mod. Okay, same we will use in integration. So everyone raise your hand if it is clear.
So
Okay,
can you explain the third?
third one. Okay. So for x is greater than equal to 2, if we will check the definition of mod of x minus 1, I have raised this. Mod of x minus 1 is what? If x is greater than equal to 1, it is positive. If your number is greater than equal to 2, then definitely it will be greater than 1. Okay, Fahd? Sorry, Abdul. If your number is
Yes,
greater
sir.
than 2, then definitely it will be greater than 1. That's why the first modulus we have taken as positive. This one, the first one.
Okay, sir.
Okay. What about the second one? Second x minus 2, why we are saying? Because x is greater than equal to 2. Then definitely we have this definition of mod x. If x is greater than equal to 2, it is positive. Okay. Okay. So Abdul, I hope this is clear. Second part. Okay, Fahd. Please check the second part. In the first case, we have taken less than 1. That's fine. In the second case, first of all, we have taken x is greater than 1. For x is greater than 1, we can define the first modulus. That is fine. But what about the second modulus, modulus of x minus 2? How can we define this modulus of x minus 2? Okay, because a number is greater than 1. So there are two chances that number is less than 2. And the second chance is the number is greater than 2. Okay, Fahd? If we are saying this, then here we have two options. The number is less than 2, and second is number is greater than equal to 2. First, this is clear. That's why we have taken two parts here, that the number is less than 2, and the third part we have taken number is greater than 2. So now this question is converted in the question of inequality. So all of you, please check that the function is continuous at x is equal to 1 or not, x is equal to 2 or not. Rifat, you have done by the same method? Rifat, you have solved this question by the same method or a different method? Oh, okay, great. So all of you, please complete this and let me know the answer. Abdul, do you still have a doubt in this question?
No, sir.
The concept which you were telling why we are not taking 1 plus h, that is clear now? Okay.
No, sir. Can we?
Oh, yes. Always remember, whenever you have a modulus, then please define the modulus. Okay. Why you were taking 1 plus h? I do not understand this. Normally 1 plus h we will take for the RHL. Okay, if you have only x minus 1 plus x minus 2, okay, then why you are taking 1 plus h? Okay, please don't do this don't do like this. In case of modulus, always define the modulus. Okay, now this become a question of inequality. Now please check for 1 and then check for 2. Okay, for 1, LHL you will use this function, RHL this. For LHL for 2, this one, RHL for this. Okay, so all of you, please try this question and let me know the answer. And still, if anyone have a doubt, please let me know. Okay, so Umair, your doubt is we were giving the inequality in the question itself or we created them by ourselves. In case of modulus, Umair, we always expand the modulus. We will always define is a better word. We will always define the modulus. So in this case, inequality was not given, but yes, modulus is given. That's why we have defined the modulus. Okay. So I already told you that in inequality questions and in modulus question, you need to use the LHL and RHL concept. Okay, Omid. Please complete this. Find this for 1 and 2 and let me know that this function is continuous at x is equal to 1 or not. And from today, you have a 2-hour class. Okay. All of you, please let me know if it is done, okay? Or if you have a doubt, then please tell me, I will solve this question. Yes, Fahad. Yesterday we have discussed that for inequality and modulus, we always used to have to use LHL and RHL concept. Okay, so please solve it. And Fahad, let me know if you have a doubt in this. Okay. Abdul, for both the points? For both the points, it is continuous. Yes, that's correct. It is continuous for 1 and 2. Very good. So Abdur has completed this. Fahad, Rifat, and Umair. Rifat, I guess you have already done this question. So Umair and Fahad. Okay, okay, Abdur. So Fahad and Umair, please complete it and let me know if you have any doubt. Okay, Umair, very good. Okay. So find F1 that is also equal to 1. So that means it is continuous at x is equal to 1. Great. Now please check for x is equal to like you can't hear me. Fahad, is it done? Fahad, you have checked for x is equal to 1. If you have doubt, Fahad, please let me know, okay? Abdur, it is continuous. Very, very good. For both the points, Fahad, or for one only? You got it for one. Very good, Fahad. Please check for next. X is equal to 2.
So can you explain like how did we get the minus x minus 1 and plus x minus?
Which case?
So the starting part, like where we defined the modules.
Okay. For x is less than 1, why we are getting negative here?
Yes, how are we getting minus x?
Okay. So we will define first of all, just give me a minute. We will define first of all this modulus of x minus 1. Okay. So mod of this x minus 1 is what? Can you explain this to me? Abdur, what is mod of x minus 1? The reference point is 1. Okay. I already explained you. For x is greater than equal to 1, it is x minus 1. For x is less than 1, it is minus x minus 1. Okay, Abdur, this is clear?
Uh,
Sorry, Abdur, you are not audible.
so how,
Sorry, Abdur.
so how we got?
Okay, then Abdur, can you define this mod of x?
So for let
Abdur, you are not audible. Mod of x, how can we define this mod?
so greater than 0 we get x.
Yeah, for x is greater than equal to 0, we get a x. For x is less than 0, we get a minus x. Okay.
Yes.
How we get this 0 here? Why we are taking reference 0? So what I told you, whatever the expression you have inside the modulus, equate that with 0, and that will give you the reference point. Here we are getting a 0. That's why our reference point is 0. If we have a modulus of x minus 1, then we need to equate this expression to 0. We will get a 1. So our reference point is 1. So if we will write x is greater than equal to 1, then this should be positive, and less than 1, this should be negative, as we have checked here. Okay, Abdul, is it clear?
Yes, sir.
Okay,
Let's
great. Okay, great. So please complete the second part. Let me know once it is done so that we can start the next question. So all of you, please let me know once you will check for x is equal to 2 also. Okay, Abdur, very good. It is correct. Fahad and Amir, please confirm the second answer. Okay, Fahad, I will solve the second one. Okay, so this is second one. So we will first find LHL. LHL at x is equal to 2. So that means limit x tends to 2 minus fx. Fahad, can you tell me for LHL what function we will use? First, second, or third? Fahad, which function we will use for the LHL? We have this one. This is the first one. This is the second one. And this is the third one. Okay. So for which one we will use? First, second, or third? If you have a doubt first, you can tell me. Abdur, can you tell me for LHL which function we will use?
So second function.
Very good. For second. Okay. So 2 minus means we are approaching from the left side. So the value is slightly less than 2. And you can see here in the second, the value is less than 2. So we have this function 1. So what is the method? Put x is equal to 2 minus h. So what, and in the bracket always write this, here the h will always tends to 0 when x tends to 2 minus h tends to 0. Okay, so here you will get what? Limit h tends to 0, and this is what here you have 1 only because we don't have any variable. We can't put in place of x anything else, anything. So we have 1 here. So what the answer we will get? A 1. So LHL we get a 1 here. Is it clear, Fahad? Fahad, is it clear? X is 2, x tends to 2, Fahad. Actually, you have missed yesterday's class. That's why you're facing the confusion. X tends to 2. X is going towards to 2 from the left side. So that means the value is slightly less than 2. That's why we are taking the second function. Okay. Okay. For please check the previous recording lecture. Okay. We have done many questions yesterday. Now next one. Next is we need to find RHL. RHL at x is equal to 2. RHL at x is equal to 2. So we will write like this: limit x tends to 2 plus fx. This is equal to limit x tends to 2 plus. 2 plus means we are approaching from the right side. That means the value is slightly greater than 2. That's why we will take the third function, 2x minus 3 here. 2x minus 3. So for RHL, you already know that we have to put x is equal to 2 plus h. So what we will get here? Limit in the bracket, always write h tends to 0. So here write when x tends to 2 plus h tends to 0. So limit h tends to 0. Here what you will get 2 into 2 plus h minus 3. Now you can put this limit. So you will get 2 plus 0 minus 3. Open this bracket, 4 minus 3. So this is equal to 4. So that means LHL at x is equal to 2 is equal to RHL at x is equal to 2. And this is equal to 1. Okay. So that means limit x tends to 2 fx is equal to limit x tends to 2 fx is equal to 1. Okay. Now we will find the value f2. So for f2, what function we will use? This one. Please check here. Here the value is x is greater than equal to 2. So if we need to find f2, then we will use again this function 2x minus 3. So f2 is equal to 2 into 2 minus 3, which will give us 4 minus 3 is equal to 1. So here limit x tends to 2 fx is equal to f2. Hence the function is hence the function is continuous. This function is continuous at x is equal to 2. Is it clear, Fahad? Okay, great. So Fahad, please note down this, okay? And confirm me, then we will start the next question. Umair, I hope this is clear to you also. Okay, please note down this. Umair and Fahad, please raise your hands once you will do this. Once this will be done, then I will change this slide. Okay, Fahad, great. Umair, I guess you have also completed this one. Okay, I'm going to change the slide. Please let me know if you miss anything. Please note down this also first, and again raise your hand. Okay. Great. Umair, is it done? Umair, I guess Umair, you have completed this, so we are going to start the next question. This we have already done yesterday. Okay. Now next one. This question. We have to find the value of a constant lambda so that the given function is continuous at x is equal to -1. Okay. There is no inequality. That's why there's no need to use the LHL and RHL concept. Okay. So please find the limit. Please find f-1. Equate that. Find the value of lambda. Please tell me the answer in three minutes. Okay. 3 minutes are enough for this question. If anyone have a doubt, then please let me know. Okay, Abdul, what the answer you were getting for that question? Uh, that is continuous. Okay. Let me check this. Okay. I guess that was a continuous. Abdul, could you please tell me the question? Okay, let me check. That question was 2 minus x and 2 plus x, I guess. Am I correct? Abdul, will you please confirm me the question? That was 2 minus x and 2 plus x.
No, sir. 5x minus 4.
Okay, 5x minus 4 and 4x cube minus 3x.
Yes.
Okay, that's correct. That is continuous. Okay, very good. All of you, please complete this question and let me know if anyone is facing issue in this one. Rifat, Abdur, Umair, Fahad, is it done?
So should we solve the x square minus 2x minus 3? Or
Yes, we need to solve this. Please check here. So in this question, it is given that the function is continuous. Function continuous means we will first calculate the limits. Limit x tends to -1. Fahad, can you tell me which function we will choose, the first one or second one, when we are calculating this limit?
Second one.
Second one? No, not correct. Fahad, actually, we have discussed
so
this
for
yesterday. First one. Fahad, please check here. This number x is approaching to -1. It is not equal to -1. When we were discussing the limits, I told you that what is mean by when we say that limit extends to a, fx is equal to b. This means x is approaching to a, x is not equal to a, x is approaching to a, x is going towards to a. That's why while calculating the limit, we will use this function because this is not equal to -1. Okay, Further, is it clear now? Fahad, is it clear? Yes, first one. Because first is not equal to -1. When we are saying that x is approaching to -1, that doesn't mean that x is equal to -1. This means only x is going towards to -1. It is approaching to that value. Okay. So we will use this value. Now this is equal to limit x tends to -1. Okay, rationalize the numerator, x square minus 3x minus plus x minus 3 by x plus 1. So here you will get limit x tends to -1 and take common plus 1 x minus 3 by x plus 1. Okay, and this is equal to limit x tends to -1 and this is x plus 1 into x minus 3 by x plus 1. This part will cancel out. So you get here limit x tends to -1, x minus 3. Now put this limit. So -1 minus 3, this is equal to -4. So we get this limit. Now we will calculate f minus 1. So first, can you tell me for this f minus 1, which function we will use? First or second? Second, very good. So here we will get a lambda. Now it is given that fx is continuous. Fx is continuous at x is equal to -1. Hence, limit x tends to -1. Fx is equal to f minus 1. Okay. So what we will get here, limit x tends to -1 means -4. -4 is equal to lambda. So that means lambda is equal to -4. Okay, this is the answer. So Rifat, are you getting the same answer? Abdur, Umair?
So can you show the previous screen?
Yes, yes. Rifat, you're getting the same answer?
Yes.
Oh, Abdur, you are not audible.
Yes, sir.
reply.
Yes, sir.
Okay, great, great. You didn't finish, Rifat? Okay, no issue. Please note down this. Okay, I will give you one more questions. Sorry, I will give you one more question of this type. Okay, so all of you, please raise your hands once you will note from this slide so that I can change it. Umair, your doubt is how did it become 3x minus? Where it is 3x minus? In which step, Umair, you have a doubt?
In the second step.
The second here, we have taken common. From this x and minus 3x, where we have taken x common. From the next one, we have taken 1 common.
And so how 2x minus 3 became 3x plus x minus 3.
Oh, so what is the issue? We have factorized this one. There's a quadratic equation by splitting the middle term.
Okay, okay.
Okay.
Okay, sir.
Okay, so please note down this. Okay, Abdur, thanks. Rifat, Fahad, is it done? Okay, okay, Rifat. Fahad, is it done? Okay, great. Amir, please confirm once it is done so that I can change the slide.
So can you show the second slide?
Yes, please note down this. And again, raise your hands, okay, once it is done. Okay, Abdur, very, very good. Okay, Rifat, good. Umair and Fahad, please confirm. Is it done? Shall we start next question? Okay, Fahad. Umair, is it done? Okay, so there are only 4 lines. I hope everyone has done this. I'm going to start next question. If anyone has missed anything, please let me know. Okay, this is a very, very good question. This came 4 times: 2002, 2010, 2011, and 2012. Okay, you need to find the value of a and b. This function is continuous at x is equal to a. So first of all, please tell me what will be your approach. Anyone can tell me what is your approach in this question. Please think for
So
one or
we'll
two.
use LHL and RHL.
Yeah, great, great, great. So please complete this and let me know. Okay. So I hope everyone is doing this question. Okay, so find the value of a and b. So this function is continuous at x is equal to 1. So please find LHL. LHL at x is equal to 1. Limit x tends to 1 minus fx. Okay. Who can tell me? Omer. Omer, please tell me for this LHL, which function you will use. And please reply me right now.
It's the third one.
Third one, very good. So this is limit x tends to 1 minus, and the function is 5ax minus 2b. So our method is put x is equal to 1 minus h. So this will become limit h tends to 0. If x is less than, yes, if x is less than 1, then for LHL, we will use that function. Okay. When x approaches to 1 minus h approaches to 0. Okay. So here we will get what? 5a, and in place of x, we will put 1 minus h minus 2b. This is equal to limit h tends to 0. Okay. Or it is better if you will put this limit. So 5a 1 minus 0 minus 2b. This is equal to 5a minus 2b. Okay, so we get this LHL. This is the LHL. Now in the same way, please find RHL. Okay, Umair, for RHL, which function we will use?
The first one.
The first one, very good. So please complete this and share your answer. Very good, Abdul. It is correct. Okay, great. So I'm going to start the RHL. RHL at x is equal to 1. Okay, so this is limit x tends to 1 plus fx. So for RHL, we will use the first function 3x plus b. Okay, 3ax plus b. Now put x is equal to 1 plus h. So here we will get what? Limit, and the bracket always right when x tends to 1 plus h tends to 0. Now limit here we will get h tends to 0. 3a in place of x, put 1 plus h plus b. Put this limit 3a plus b. So this is RHL. Okay. And now we will calculate f1. Okay. Who can tell me? First, can you tell me for finding the f1 which function we will use? There are three: first, second, and third. Very good, for second one. So what we will get here, f1 is equal to, it is already given 11. Now, it is given in the question that fx is continuous at x is equal to 1. At x is equal to 1. So that means limit will exist because the function is continuous. So that means LHL at x is equal to 1 is equal to RHL. Okay, LHL and RHL should be equal because the function is continuous, and that will be equal to the limit, and that will be equal to f1. So what is LHL here? LHL is 5a minus 2b. 5a minus 2b is equal to 3a plus b is equal to f1 is 11. Okay, so here we get two equations, 5a minus 2b and this one. So we can say 5a minus 2b is equal to 11. And 3a plus b is equal to 11. We get these two equations. So please solve these equations and tell me the final answer, the value of A and B. Okay. So please note down this, complete it and share the answer. Tell me the answer of value of A. Okay, Umair, then I will give a break of 10 minutes. Okay. So please tell me the answer. What the value you are getting, value of A and B? Everyone, please complete this. Tell me the answer. Then I will give you a 10-minute break. Okay. This is a simple linear equation. Please solve it and let me know the answer. No, Abdur, it is not correct. Please check here. So this is a linear equation. This is first and this is 2. Multiply equation 2. Multiply equation 2 by 2. So you will get 5a minus 2b is equal to 11. And this is 6a plus 2b is equal to 22. Okay, add this will cancel out. 11a is equal to 33. A is equal to 3. put a is equal to 3 in equation 1. So you will get 5a minus 2b is equal to 11. Put this value, so 5 into 3 minus 2b is equal to 11. So this is 15 minus 2b is equal to 11. Minus 2b is equal to 11 minus 15. So minus 2b is equal to minus 4 and b is equal to 2. Okay. So this is the answer. B is equal to 2 and A is equal to 3. Okay. I'm giving you 10 minutes break. Please have your prayers and please join back again in 10 minutes. Okay. Thank you. Okay, Abdur, actually Umair needs to go. Okay, so I thought you all are at the same location. So that's fine, Abdur. Please take a break of 10 minutes. Okay, then we will continue this. Okay, so I hope everyone is back. We will then continue our class. Umair, please let me know if you are there in the class. Next is, so all of you got the answer. Rifat, please raise your hand if you have noted down this. Fahad, Abdur, Umair. Okay, good. Abdur, Fahad. Can we, it's your wish. If you want to subtract it, subtract, but you will not get any benefit. Okay, you need to first make the coefficients equal. Okay. So you have already done this in class 10. So you just need to solve two simple equations.
Sir, after cancelling, can we subtract 5A and 6A? Or we can't?
Um, I don't understood this. We have this equation, okay? 5a minus 2b is equal to 11. And next is 6a plus 2b is equal to 22. Okay. Now, if you will subtract it, then definitely the sign will change here also. So in complete equation, the sign will change. Okay, so we will not subtract it, we will add this so that this will get cancelled out and here we will get 11 is equal to 33. Is it clear, Abdul?
Yes, sir. Yes, sir.
Okay, okay, that's great. So um, we will start next question. This question you have to do in homework. Okay, this is a very, very good question. This also came in 10, 12, 13. This is also present in the examples in your, sorry, NCRT example. Please note down this and raise your hands so that we can move to the next question. Okay. Okay, all of you, please raise your hand if this is done. Okay, Rifat, very good. Abdur, Fahad, please raise your hand if this is done. Fahad, very good. Abdur, is it done? Okay, great. Now next one. Okay, so next we have a theorem. Okay. The theorem is f and g be two real functions continuous at a real number c. Okay, so we have two real functions, two functions. First is f, second is g, and it is continuous at x is equal to c. Okay, both the functions separately are continuous at x is equal to c. Then what will happen first is if you will add these two functions, it will be continuous at x is equal to c. If you will subtract these two functions, it will be continuous at x is equal to c. If you will multiply the functions, it will also be continuous. If you will divide the function, it will be continuous. Okay, provided the denominator should not be equal to 0. As I already told you that in denominator, we never should have a 0. Okay, so what is this theorem? If you have two functions which are continuous at particular point, if you will add those two functions, if you will subtract those functions, if you will multiply those, if you will divide those, then the result will also be continuous at that point. Okay, so I hope this is clear to everyone. Please note down this, raise your hands once it is done so that we can move to the next topic. Okay, all of you, please raise your hands if it is done. Okay, Abdur, very good. Rifat, Fahad, Umair, please confirm if it is done so that we can start the next topic. Okay, Rifat, good. Fahad, please confirm. Okay, very good. So next our topic is continuous function. What is a continuous function? A function is said to be continuous if it is complete function is said to be continuous if it is continuous at each point of its domain. I hope everyone know what is a domain. Okay, so what is a continuous function? A function is said to be continuous if it is continuous at each point of its domain. Okay, now anyone can tell me what is the difference between this topic and the questions which we have done earlier. Before this one, we have done some questions like this. So anyone can tell me what is the difference between those questions and this topic? Abdul, Fahad, Rifat.
Sir, domain.
Sorry.
Sir, domain.
Yeah. So in the last question, we have checked the continuity at a single point only. Okay. If you will check all the questions, then in that, they ask you to check that the function is continuous at that particular point or not. While in this topic, we need to check that the complete function is continuous or not. That means we have to check that all its domain. For example, fx is equal to 1 by x minus 1. I already told you that in denominator, we should never have a 0. So what is the domain of this? Domain is a real number except 1. In the denominator, you can't put the 1. So we have this function. This is the domain. So we need to check that on this complete domain, okay, on this complete domain, the function is continuous or not. So in the previous questions, we have checked that the function is continuous at one particular point or not. While in this topic, we have to check that the function is continuous throughout its domain or not. Okay, so I hope this is clear to everyone that what is the difference between this topic and the previous one. So please note down this topic, confirm me, then we will start the next question. Okay, raise your hands once it is done. Very good, Rifat. Abdur and Fahad, please confirm if it is done. Abdur and Fahad, please confirm if it is done. Okay, Abdur, Fahad, great. Okay, then we will check the questions. Leave it. This we will do later on. Okay. Function f defined as this show that f is everywhere continuous except at x is equal to 4. So whenever you are getting a modulus question, then what we have to do? We have to first of all define modulus. So this we will do in the ref page. Fahad, please define this mod. Fahad, please define this.
Sir, if x is great, we'll get x minus 4, and
If okay, and if it is less than 4,
less we get minus 6 minus 4.
very good, Fahad. This is correct. Okay. So now all of you please check here. Fx is equal to our question original was this. So we will write all the cases. Okay. Here we normally take x is greater than equal to 4. Here we normally take x is greater than equal to 4. But if we will check the question, then for equal to, they have already given the value. Okay, for equal to, they have already given the value 0. So we can't take this equal to. So we will just mention x is greater than 4. This is clear to all of you. Abdul, Fahad, Rifat, is it clear to you? Abdul, Fahad, and Rifat, this is clear that why we have taken only greater than 4 and not equal to. Okay, Abdul. Fahad and Rifat, is it clear? Or you have, okay, Rifat,
So
good.
can you explain again
Yes.
this one?
For normally we take x is greater than equal to 4. Okay. But if you will check this question, then in the question, it is already given that with x is equal to 4, the value is 0. So x is equal to 4, we will take separately because it is given in the question that the value is 0. This clear for?
Yes.
Okay. Now here, when x is greater than 4, please analyze this. In the numerator, we will have x minus 4. In the denominator, we have x minus 4. Cancel out these two. Okay, cancel out these two, you will get a 1. Okay, next, x is less than 4. So we already know that then this numerator will become negative. Denominator, we have x minus 4. Cancel out this, you will get a minus 1. Okay, so we get this inequality. Greater than 4, we have the function 1. Equal to 4, we have 0. Less than 4, we have minus 1. Now in this question, what we have to show, we need to show that it is everywhere continuous, except at 4. So what we will do, we will assume, first of all, please check the steps. Steps are very, very important here. If you will understood a single question, then you can do rest of the question on your own. So please check here, k be, let k be a real number. Okay, let k be a real number. According to the question, according to this, according to the question, according to the question, k is greater than 4, k is equal to 4, and k is less than 4. Okay. So we have assumed a value k, and we are saying that k is greater than as per this value. Okay, here the x is given, we have taken that as k. Now we will divide this into cases. Case 1, when k is greater than 4. When k is greater than 4, so we will calculate the limit x tends to k fx. Then who can tell me? Abdul. Abdul, can you tell me when k is greater than 4 and we have to find the limit, then which function we will use? First, second, or third?
So first,
First one. Very good. Is it clear, Fahad and Rifat, that in this case, we will choose the first function? Is it clear?
so it must be k plus
It must be
k plus limit k plus.
no, we are not finding the LHL and RHL here. Okay, right now, what we have done, we have taken this value that k is greater than 4. We are not finding the LHL and RHL. For x is greater than 4, we have only 1. Okay, so please have a patience for 5 to 10 minutes. I will explain to you that when we will take LHL and RHL. Okay, so we have this function 1. We have find out the limit. This is 1. We just need to put the limit directly. We will get a 1 here. Next, we will find the value of k. Okay, what anyone can tell me? Fat, can you tell me what is the value? What is fk here? Fahad, can you tell me what is fk? Not 4, not 4, Fahad. Please check here. We have this function. We have this function fx is equal to 1. Okay. For this first case, we will use this function fx is equal to 1. in this function, there is no x. So if you will write in place of x k only, then you will get a 1. Now is it clear? Okay, Rifat, is it clear? Rifat, is it clear? Okay, very good. Now, if you will check the limit x tends to k, fx is equal to fk. Okay, limit is equal to xk. Hence the given function. Hence the given function is as a given function is continuous for all real numbers, for all real numbers greater than 4. Okay, for all real numbers greater than 4. So in the first case, we have taken k greater than 4. So we have proved that this is continuous for all real numbers greater than 4. Okay, I hope this is clear to everyone. Please note down this, raise your hands once it is done. And if you have a doubt in case 1, then please let me know.
So how did we get f of x equals to 1?
Okay. So for this case, when k is greater than 4, Abdul, can you tell me which function we will use?
The first one.
First one. This is what fx is equal to 1. So throughout the calculation in case 1, we will just use this one, fx is equal to 1. Is it clear?
Yes, sir. So how we got the f of k?
How we get f of k? Okay, tell me how we will check that the function is continuous or not. What is the formula? Formula is
So f of x equals to f of
limit x tends to a, fx is equal to fa. Okay, Abdul?
yes.
Okay, now check here. Fx is equal to 1. If in place of x, we will write k. Why k? Because we have to check that for k, this function is continuous or not. So in place of x, if we will write k, then in the RHS, there is no value of x. Okay, so that's why this remains 1. Is it clear, Abdul?
Yes.
Okay, great. So all of you, please note down this and let me know if you have a doubt in this, okay? Because there's a different type of question. So if you have any problem, then please tell me. Okay, and raise your hands once you noted down this. Okay, Abdul, very good. Fahad, Rifat, please confirm if it is done. Okay, Fahad, very good. Rifat, is it done? Okay, very good. Now we will check the second case. Okay, case 2. Case 2 is when when k is less than 4. Okay, so fx is equal to what? fx is equal to, who can tell me? Rifat, can you tell me which function? This is first, this is second, and this is third. When k is less than 4, which function we will use? Third one, very good. So third is -1, okay? So fx is equal to -1, very good. Now we will calculate the limit. Limit extends to k, fx, okay? So which function we will use? We will use the third one, -1. If we will put this limit k, then in this one, there is no x, so we will get a -1 on. Okay. Next, we have again fx is equal to -1. If we will find fk, then what the answer we will get? This is equal to -1. So what the final answer is? So we can say that limit extends to k, fx is equal to fk, as the function is continuous, at x is equal to, sorry, hence the function is continuous for all real number, is continuous for all real number, less than less than 4. Okay, so the same thing which we have done in case 1, we have performed in case 2. So we have proof that this is also continuous for less than 4. So all of you, please complete this, note down this, raise your hand so that we can check the third case.
So can you just show the last slide?
Yes, sure, for it.
Done, so you can change it.
Okay, for fk, how we are getting -1? This one. For Abdul, please check here. Fx is equal to -1. So in the RHS, we don't have any value of x. So if in place of x you will write k, then RHS will remain the same. It will not change. Suppose if you have fx is equal to x square, then fk will become k square. But in the RHS, we have a constant. That's why it will not change. Is it clear for now?
Yes, sir.
Okay, great. So all of you, please note down this, raise your hands, then we will do the case 3. Okay, okay, Abdur, Rifat, please confirm if it is done. Okay, very good. Now we will check the case third. Okay, case third is what? If we will check in starting, then we have taken this one. K is greater than 4, equal to 4, and less than 4. Okay, so only this is remaining. K is equal to 4. Now we have to check at this particular point. One thing always remember in this continuity, if they are asking you to check that the complete function is continuous or not. So for greater than any number, that function will always be continuous. This is a standard result. But we know we have to show this. That's why we have done like this. Always remember, for greater than, function will always be continuous. For less than, function will always be continuous if it is a polynomial function and trigonometric function like this. Where there is a possibility that the function will not be continuous, that is at this point. At this point, at 4. At 4, there is a possibility that the function will not be continuous. Okay. So what we will do, k is equal to 4. Fx is what? Abdur, can you tell me what we will take fx for the third
0.
case? Very good. 0. Good for is equal to 0. Now, fx is 0. We need to find fk. So fk is what? Fahad?
0.
0. So we get this value. Next, what we have to calculate? We have to calculate the limit. Okay. This is 0. Is equal to 0. Now we need to calculate the limit. Here we will use LHL and RHL concept. Okay. We will write like this: limit x tends to 4 minus fx. Okay, for LHL, who can tell me, sorry, Rifat, can you tell me for LHL which function we will use, first, second, or third? Rifat, for
So
LHL,
first one.
first one, LHL, I'm talking about the LHL, left-hand limit. No, Rifat, that's not correct. Abdur and Fahad, can you tell me for LHL?
Third one.
Third one, very, very good. Okay, third is x is less than 0. Please check here. Here we are approaching this 4 to the left side. From the left side, we are approaching this 4. That's why we will use the third function, which is what? Which is -1. Okay, so we will write -1 here. Please don't get confused that for k is equal to 4, fx is 0. That's fine. That's why we have used this one. But when we are calculating the RHL and the RHL, then we have to check that as per RHL, which function we have to use. So again, same thing, put x is equal to 4 minus h in the bracket, right? When x tends to 4 minus h tends to 0. So here we will get what? Limit h tends to 0 minus 1. Okay, because there's no x, so we can't put any value. We will get -1 only. Next, similarly, we will calculate RHL at x is equal to RHL at x is equal to 4. So we will write like this: limit x tends to 4 plus fx. Now next is Rifat again. Rifat, can you tell me for RHL which function we will use? Rifat, for RHL which function we will use? Abdur, can you tell me for no, no,
First
Rifat.
one.
First one. Rifat, please check here for RHL. RHL means 4 plus. You are approaching from the right side. So that value should be 4 plus, greater than 4. So that is 1. We will use the first function. Okay, limit x tends to 4 plus 1. Okay. Now, please write here, put x is equal to 4 plus h when x approaches to 4 plus h tends to 0. This is equal to limit h tends to 0, 1. So we will get the 1 only. So we can say that limit x tends to 4 minus fx is not equal to limit x tends to 4 plus fx. Hence limit x tends to 4 fx does not exist. Okay, does not exist. Hence so the function is not continuous, at x is equal to 4. Okay, so please note down this, raise your hands once it is done, then I will summarize the result. Rifat, please note down this, okay, and confirm me, then I will summarize the result. Yes, Abdur. For less than and more than, we don't need to prove LHS and RHS. And in most of the cases, for less than and greater than, the result is you will find it as continuous. Okay, in 99.9 cases, you will find out this as a continuous. So we just need to focus more on that particular point. Okay. So, okay, Rifat, Abdul Fahad, is it done? Is it done, Fahad?
Sir.
Okay, great. Now I will summarize this. So please check this. For this inequality, for greater than, you will find out that this is always continuous. For less than also, you will find out this is continuous. Only at this point, only at that particular point, there are the chances that the function is not continuous. Okay. So I'm going to erase this. You all have already done this. So now rest is homework. Okay. Please note down this. I will give you just 1 minute to note down this. Please note down this, raise your hands, then we will check the next question. Your class is over. I have to give you the homework. Please note down this in 1 minute on. Okay, Rifat, good. Abdur and Fahd, please raise your hands. Okay, Abdur, good. Fahad, is it done? Great. Next, this is also a homework. Okay, again a modulus
So
function.
for this, we don't have to find the domain, right?
No, in no question you have to find the domain. Okay, as this is a modulus question, so you have to define the mod. This question. In this question, inequality is already given. This is a mod question, so you have to explain this, that value of mod, as we have done the previous questions. Which question, Omer? This one? This question, Omer? Omer, please let me know if this is done. Omer, I guess you have done this, so I'm going to change the slide. Please let me know if you miss anything, okay? This one. All of you, please note down this and again raise your hands. So this week, please first of all do these questions which I have given from the slide. After that, solve the assignments. Okay. Okay, Rifat, good. Abdur and Fahad. Okay, Abdur, very good. Fahad. Okay, great. This question is also a homework. Okay. This question came in CBSE 2002. Again, note down this and raise your hands. Okay, Rifat, very good. Abdur and Fahad, please confirm. Fahad, good. Abdur, great. Uh, okay, there's so many questions. Okay, please note down this. This is also a homework. And again, raise your hand, please. Good, Fahad. Good, Rifat. Abdur, is it done? Okay, very good. Next, this one. This is also a homework. Okay, please note down this. All of you, please raise your hands once it is done. Okay, Rifat, very good. Abdur and Fahad, please confirm. Good, Fahad. Abdur, is it done? Is it done, Abdur? Great. This is the last question. Okay. Yes, this is the last question for. Okay, then your continuity is completed. In next class, we will start differentiability, but we will discuss the doubts. Okay, whatever the doubts you have, we will discuss those. So the questions which I have given from the PPT, please complete those questions. These are very, very good questions. I will I will discuss your doubts and we will start differentiability also. Okay. Please raise your hands if this is done. And next week you have you have a test of differentiation. Okay. Today I do not have the time to take your test. I will take next week. Please raise your hands if this is done. Good, Rifat. Okay, Rifat, if you wish, you can drop off from the call. Okay, I'm just going to handle it. Abdur and Fahad, please confirm if it is done. Okay, Abdur, very good. So Abdur, if you wish, you can drop off. Okay. Uh, yes, we can discuss the question paper. Second one. Okay, Fahad. Just give me a minute. Okay, Fahad, is this done?
Yeah, sir. Done.
Okay, great. So we will discuss the second one. Just give me a minute.
Done, sir.
Okay, Abdur, very good. So Abdur, if you wish, you can drop off. Okay, I'm just going to end the class.
Thank you very much,
Okay,
sir. Nice, sir.
okay, you're welcome.
Thank you, sir.
You're welcome. Bye-bye. Okay, second one.
Yes, sir. Second question.
Okay, okay, okay. X is equal to a cos t plus log tan t by 2. Y is equal to a sin t. Y is equal to a sin t. Next, dx by dt. So this is equal to what? A remain as it is, minus sin t plus 1 by tan t by 2. Derivative of tan is sec square t by 2 and into 1 by 2. Okay. So dx by dt is equal to a into minus sin t plus this 1 by 2 I will write here. This tan we will write sin by cos into cos t by t into sec we will write here 1 by cos square t by 2.